Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Ashraf and my metric number is 181208.
And my name is Syarul Hazrimi bin Ahmad Nafia. My metric number is 183076.
My name is Muhammad Faiz Shamil bin Alman. Metric number 181331.
My name is Muhammad Iman Firdaus bin Marustan. Metric number 181471.
Okay, we from section 600 and I'm going to explain about the question 10 from previous Obt question. Near the surface of the earth, there is an electric field of about 150 volt over meter, which points downward. Two identical balls with mass of 0.54 kg are dropped from a height of 2 meter, but one of the balls is positively charged with Q1, which is 650 μC, and the second is negatively charged with Q2, which is negative 650 μC.
First, we go to the sub-question, which is with the aid of the free body diagram, explain why they hit the ground at different speed. So based on the question, we know that there are positive charge and negative charge. So the electric field, we also know that the direction of the electric field point downward. As we learned in the lecture, the direction of the electric field is always same as the direction of electric force for the positive charge. So for the positive charge, the free body diagram is like this. So the first force is the gravity force, which is mg, and we know that the electric field point downward. The value is 150, and the electric force is always same as electric field for the positive charge. Then we draw this EQ. So the energy of the positive charge will be added with the electric field. So that's all.
I will explain about the negative charge.
Negative charge. So mg is downward. So same as positive charge, electric field always downward. Electric field, but for the electrical force, it opposite from for the positive charge, it lift upward. QE. So that's why positive charge hit the ground first, then negative charge.
Okay, now I will explain why they hit the ground at the different speed. I will conclude the answer for question A. Both of them hit the ground at different time because of the electric force of each charge is different. So for the positive charge, the electric force is pointing downward. However, for the negative charge is pointing upward. Due to this direction of electric force, the speed of each charge are different.
Okay, now I will answer the question B, which is ask us to use the conservation of energy to determine the difference in the speed of the two balls when they hit the ground. Neglect the air resistance. For the positive charge, it experiences a downward force due to the electric field, and it falls down. The electric potential also will decrease. So, the kinetic energy, the conservation of energy equation for positive charge will be kinetic energy equal to electrical potential energy plus gravitational potential energy. Okay, from this equation we know that it is half mv squared equal to QEH plus gravitational mgh. Note that this h is the distance that the charge travels through the electric field. So from here we have to find the V. So the expression of V will be this 2h mg plus QE over m square root. Then just substitute the value, which is the h will be 2 and mass of the charge will be 0.54 multiply with the gravity 9.8 plus the charge, which is 650 times 10 of -6, and the E, which is 150 over the mass, which is 0.54 square root. So from here we'll get the V for positive charge is 6.32 meter per second. Okay, for negative charge, we know that the electrostatic force is pointing upward and it opposing the falling motion, so the electric potential will be increased when it falls. So the conservation of energy equation for negative charge will be Ke equal to mgh minus with QEH. Sorry, this is half mv squared. So from here we will find the V expression, which is 2h mg minus QE over the mass square root. Then we just substitute the value, which is 2. The mass is 0.54 times 9.8 minus 650 times 10 of -6. The E is 150 over the mass 0.54. So from here we get the V for negative is 6.2 meter per second. Okay, so the question asks us for find the difference in the speed of the two balls. So here we'll just use this question. We just find the difference, which is delta V equal to the V of positive charge minus the V of negative charge, which is 6.32 meter per second minus 6.2 meter per second. The final answer we will get 0.12 meter per second. Okay, that's all.